Well, good morning and welcome back to Mystery Math. We're going to take some of the mystery in math and make it past tense. And once again, I'm reacting to the test that we had recently. This is the third video I've made. The first one is about trash answers and what to do with them. The second one, I'm showing you my methods on how to do some of these problems 1 through 12. And I got up to question number 7. I got that done. We're going to finish out 8 to 12, hopefully on this video. And then 13 and 14 I'm going to show you in class because there's a little more work involved in those, but even those really aren't that terrible. But let's jump right in with question number 8. Okay, again, these are my methods. This is how I would do it. I've got more in-depth options that you all can check out and other resources as well, but super easy ways to deal with partitions. Okay, so number 8, line segment JL, and I've drawn that here. Contains point K. K is floating somewhere in here. I don't know where yet, okay? Where the length of JK, so from J to wherever K is, that's 2/3 the length of the line segment. Now, if you think about it, if I'm 2/3 to L, then how much is left for this other portion? 2/3 is over here, there's 1/3 left. Okay, so 2/3 is actually the ratio. That's the K value. But if you think about it, how many thirds are on this side? 2. All right, how many thirds are on this side? 1. So this is a 2-1 ratio. Okay, there's 2/3 over here, 1/3 over here. I need to divide this line segment into 3 chunks, and then I need to put 2 of them, I need to find that point that puts 2 of them over here and 1 of them over there. So what I'm going to do is I'm going to draw my helper line, come straight out, because helper lines are a lot easier to split up. Okay, these diagonal lines that go through, we need Pythagorean for that. Or the distance formula. That's a lot harder. But I can draw a helper line, I put it in line with this point L up here, and I'm just going to chop that into 3 pieces, if I can. Let's see, how long is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. When you know it, 15 is divisible by 3. Crazy, right? It's almost like I intended it to be this simple. 15 divides by 3, you get 5 chunks, or 5 pieces per chunk. So what I'm going to do is I'm going to count 5. 1, 2, 3, 4, 5. There's one of my division lines. 1, 2, 3, 4, 5. There's one of my division lines. Now I have 3 pieces that are 5 units long. I've divided my 15. I want to put 2 of those chunks on the left side and 1 on the right. Okay, so this is my line right here. It's going to get me there. My point is going to go right there. And all I do is I just look at the origin. This is 0, 0. I'm going to go 1, 2, 3, 4 for X, and 1, 2, 3, 4, 5 for Y. So my point is at 4, 5. I have now partitioned. Okay, let's look at, that's number 8. Let's look at number 9. Okay, I've got a drawing here on number 9. I started running out of graph paper. I'm sorry, it's bleeding through on the other side a little bit, but we'll make it work. Number 9 right here. I've got points for my line. First thing I'm going to do, graph it. Okay, so let's take that negative 4, 10, boom. That 4, negative 6, boom. All right, I've got those plotted. I use a straight edge to draw my line. Use a straight edge, folks. All right, and then I'd love to be able to divide that. There's a 5-3 ratio. That means there's 5 parts on the left, 3 parts on the right. Okay, that means there's a total of 8 parts. Or there's 5 parts from this point, and there's 3 parts next to this point. Okay, it just happens to be this one's going left, right. So I want to find that division between 5 and 3. How many parts are there total? There are 8. Okay, so what I'm going to do, again, is I'm going to draw a helper line. I'm looking to see where my target is. This will put me in line with that. So here's my helper line. All right, I want to divide that into 8 same size sections. So let's see how big it is. 1, 2, 3, 4, 5, 6, 7, 8. Once again, I'm telling you folks, it's almost like we wanted you to be able to solve these, right? All right, it's 8. It's divisible by 8. So that means 1 unit per part. Okay, so I'm just going to put a mark at each one. Now I want to put 5 of those divisions on this side and 3 on this side. So here's 1, 2, 3, boom, right there. Okay, that's going to be the line. I'm going to extend this up until I get there. Pow. That is my partition point. That would be X equals 1, Y equals 0. Okay? All right. Too easy. All right. Number 10. And I'm going to turn the page over. We've got the last 3 that I'm going to do for you this way. These my versions. These hacks on, hacks off. All right. So number 10. The 2 endpoints of lines. All right. 2 endpoints. I'm going to plot the points. Boom. 2, 6, and 12, negative 4. Done. All right. I'm looking for point T. Point T is floating in here somewhere, such that line segment RT, that's from this point R to, I should have written R, there's R, and there's S, Okay, so wherever t is, rt is going to be 3 of the parts, and ts is going to be 1 of the parts. So I'm going to have 3 of the parts on this side, 1 of the parts on this side. How many parts are there total? 4. I want to divide this into 4 even parts, but it's a diagonal line. I can't do that so easy. So I'm going to draw a straight helper line, and I'm going to hope that it's divisible by 4. Let's find out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh my gosh, I can't divide 10 by 4. Sure I can. It's 2.5. Okay. Yes, it's a decimal. It's a little more complicated, but it's not really that bad. What I do is I go from this point, 1, 2, and a half. Boom. Then I go, there's a half, and then 1, 2. So there's another one. Boom. And 1, 2, and a half. Folks, if you had a piece of wood that was 10 inches long and you needed to divide it into 2.5-inch segments, could you do that with a ruler? Yeah, it's the same thing here. I've got 10 units. I'm chopping them into 2.5 unit blocks, okay? So here we are. There's 4 evenly distributed partitions, okay? Now I want the one that puts 3 on this side and 1 on this side. This one right here, okay? There's 1, 2, 3 on this side, 1 on this side. I go straight up and pow. And I can see already that it's halfway between that point, so it's 2, 3, 4, 5, 6, 7, 8, 9.5 would be my x value, and then negative 1.5 would be my y value. Now folks, this one, because it uses decimals, if you feel better using the steps, using the formula that I showed you how to do, I understand that in this case. This really was the hardest problem on the sheet, but because it was multiple choice, this was probably actually the easiest problem on the test because of the answers that couldn't possibly be correct. But even if you're having to work this the hard way, this one is a little bit more difficult because of the decimal. All right, but other than that, it's really not that hard. So, all right, now let's move on to 11 and 12. 11 and 12 are just distance, okay? So the way I do it, I'm gonna do this your method and just go through it pretty quickly because, I mean, really, because we're using the TI-84s, that's really the best way you've got. So here's x1, y1. Here's x2, y2. And what you're going to do is you're going to take 8 minus 3 squared plus negative 6 minus 4 squared. All right, and that, if you put that right in your calculator, you know, you're going to get the decimal really quickly. And then what you're going to do is you're going to convert these to decimal to see which value matches your value. Okay, now the way I would do it is I would say the square root of 8 minus 3, that's 5, all right, squared, plus negative 10 squared, and then the next level it's 25 plus 100, and then it's a square root of 125. All right, and what I have to do really is I have to simplify that without teaching you a whole unit on simplification. I'm just going to tell you what I would do is I would put that into your calculator, figure out what the decimal is, and you're going to find out that this one has a decimal that matches it. All right, but yes, that simplifies down to 5 radical 5. Okay, now this one, the main thing you all need to make sure you get right really is just the setup for that first equation. Okay, as long as you get that in the calculator the correct way, most folks have not been having a problem with these. Okay, so x1, y1. Okay, we're going to take the x2 minus x1, so 9 minus 1 squared plus 17 minus 5 squared. Okay, and you put that in there. There are no weird negatives you have to deal with. These two were pretty easy for distance. Okay, but I'll tell you, 9 minus 1 squared, that's 9 minus 1 is 8, and then 8 squared is 64, so I end up getting 64 plus, and 17 minus 5 is 12, 12 squared is 144, so now I'm going to add those together. I end up with the square root of 208, and then it just becomes an issue of needing to reduce that to the simplified version of the radical, and that's it right there, the one that I just circled, B. Okay, I've shown you my hacks on, hacks off version. I just got through these first 12 problems in less than 10 minutes because I looked at the speed ways that I've been done it. And it really, if I hadn't been talking to you, I probably could have done them all in about 5 minutes. Okay, so it takes practice, folks. It takes reps. But there we go. Hopefully you can use some of this video to help you, because if you're making corrections, you're going to have questions to deal with that don't have multiple choice answers. So you need to have effective ways to do this. Y'all have a great day. I'll see you later.